Let's take a look at Newton's first, second, and third laws when applying to a crane. And a crane is used in construction sites to lift very heavy objects such as metal beams. So, Newton's first law deals with the concept of inertia. And inertia describes an object's tendency to keep its motion. If something is at rest, it will stay at rest. If something is in motion, it will stay in motion. The only way that this will change is if an unbalanced force acts on an object. Unbalanced force. And that should change its motion. So for example, here, imagine that our crane has stopped pulling and our metal beam is hanging motionless in the air. So the inertia that we could describe here would be motionless. Now imagine that we wanted to change that inertia. We wanted to change the motion. The only way that we could do that is to apply an unbalanced force. So for example, the crane operator could start the lift and pull that piece of metal upward. This is a force of a pull. Here, the inertia would change from motionless to in motion. And we did that by applying an unbalanced force. So there is Newton's first law applied to a crane. Let's take a look at the second law. Newton's second law explores the relationship between force and mass and acceleration. Force, mass, and acceleration. Acceleration has to do with the change in velocity or speed of an object. Now, imagine, if you will, that first we'll look at forces and then we'll look at mass. So imagine, if you will, here, our crane operator has two pedals. One pedal will lift our hook with a giant force, with a very large force of the pull. That's our first pedal. Imagine that our second pedal then is a little bit slower. It pulls it at a steadier speed, so it uses less force of the pull. In these two instances, we would observe different accelerations. Here, with my green pedal, the force is greater, so then the acceleration is greater. When you compare it to the red pedal that pulls it with a steady, smaller force, so our acceleration is lower. And that makes sense. If you pull your crane with a giant force, it's going to move faster upward. It's going to change its speed faster. As opposed to a smaller force, it's only going to pull that crane up just a little bit, so it's going to move more slowly. Okay? Now, let's take a look at mass. So here, let's imagine that we've got a crane pulling one type of metal, and then we've got another crane pulling a metal bar. It's a little bit more massive, and I'm going to color it red so we can see the difference. So look here, we've got this bar, which has a lower mass. This bar has more matter, more stuff, so it has a greater mass. We could even say that this is 100 kilograms, and this one is 700 kilograms, just to put numbers to it. So if we were going to move these objects, the object with the greater mass is going to have a smaller acceleration. And that makes sense. If we want to move something that has more matter, more stuff in it, it's going to move at a slower speed. If you compared it to a piece of metal or a metal bar with a lower mass, it's going to have a greater acceleration. So, in essence, when we look at force, when you increase the force, you increase the acceleration. When we look at mass, the more massive an object is, the lower the acceleration. Notice the difference in relationship. This is a directly proportional relationship. This is an inversely proportional relationship. So there is Newton's second law applied to the crane. Now, Newton's third law, his final law of motion, deals with the concept of action and reaction. Action and reaction. So Newton actually says that for every action in the universe, every action has an equal and opposite reaction. I want to make sure that I highlight these two words here: equal, opposite. This is key. So imagine here, my crane, I'm lifting it off of a cliff. So there is a force of gravity that pulls our crane downward. But I already told you that our piece of metal is at rest. It's motionless. It's at rest. So in order for this piece of metal to not just go straight down to the ground, there has to be an equal and opposite force acting. Here, that would be the force, the normal force, or the force of the metal pushing up against gravity. So it balances out to be motionless. Another example of Newton's second law, equal and opposite reaction, is we could see with our car. Same thing, we have a force of gravity and a normal force, but we also see too that there is a force that's keeping it from rolling downhill. So if we wanted to say that our force of motion or acceleration, our car is trying to go in this direction, let's say a force of acceleration or force of motion, there is a force that is equal and opposite in magnitude and direction, and that would be the force of static friction. So here we'll see static friction equal and opposite to the force of acceleration of the car, which is why the car stays motionless. So we went through all of Newton's laws, first, second, and third law. We applied it to a crane. And every time that there is an action, or every time there's an interaction in the universe or motion, you can think of Newton's laws.